So now, having finished the cross-feed modification and repair, I think I can go through what I've done. And mainly it was done to minimize the play that I saw I had, around 20 to 30 hundredths of a millimeter play. The majority of this was because of a worn nut here, and the nut being brass really, so they cheaped out a little bit there, is now modified with an extra section here, just the silver solder onto it, which reduces the play to around 2 to 3 hundredths of a millimeter. So this is as low as I can go, I think, without binding up anything. And this was accomplished by silver soldering here. I actually entered the screw here, or not this one, but similar, snugged up the two parts together and silver soldered. A bit afraid that I would weld up everything or solder up everything, but that went okay. And then the other thing I wanted to really to improve was the bearing here. As it is with just a bushing, and now I added 2 thrust bearings. And on this side I have the washer and the bearing and washer. On this side just the needle, bearing and washer, because I wanted to have this as slim as possible. But still I had to do something about the length here. I have shortened this flange here a little bit, and also then shortened the middle part here also, the bushing, and I also then slimmed off this. Couldn't go any further on this part, that's why I didn't include the washer there, because this is already thin enough here. So I can't go beyond that because I need the diameter. As is, also this needs to be flush with this side. I had to recess make a bigger hole here. I'm in the process of modifying the cross-feed nut bearing block here to accommodate a pair of thrust bearing with washers on this side. This has to be flush with this side. And these bearings I have, they are too large, so I have to enlarge the hole there a little bit. And then this bushing will go in there to be fixed by the screw here on the side. And then there will be another thrust bearing pair on this side. And of course there will be a collar here, a dial, and then the hand wheel. I'm boring out this hole now. I know these are wooden blocks, but they provide sufficient support, at least for now. I contemplated on boring them out in a lathe, but found that this was probably the better method. So using my Grandlund boring head, I will bore out to the diameter of these washers. And to of course a depth, so I can accommodate them. I've set 0 on the dial there, up there, and then go down. I take it in increments. We'll have to move the screw here a little bit down because of this arrangement or rearrangement, but I think that'll go okay. So that this is now flush here, so it doesn't interfere. And that's why you can see here that on this side, as you see here, there is a certain amount of room. I wanted to have that at a minimum, hence I did not include the washer. Of course, not ideal. I mean, the one side of this here will be towards the non-hardened but still ground surface of the original bushing, but we'll see. If I need to do something, I can, and then probably will introduce some kind of cover. But the reason I wanted to have this as close to as possible to the original here is that there is only a certain amount of room left for the key to enter the hand wheel. I need an extra hole here because this hole interferes with the new set in here. So this one will be here and a little bit towards the end there. And the hand wheel was the last thing I wanted to show that I have repaired. I could have welded it up, but I'm a lousy welder, and also I thought that silver soldering is a good alternative. So to reinforce it a little bit, I entered made two rings up. So then I silver soldered all this together in as one piece. I think that went okay, really. So of course, everything as it is, I guess the most cost effective would be to buy a new unit anyway. And then I made a slot here, a screwdriver slot, so that I could enter this in here, and then also I will secure it with glue. So that's a useful repair and modification, I think. So preparing to test my adapted crossfeed nut. No matter what I did here, I still had some play in the nut, and it was the nut itself. So now I have added what is apparently a not a brass nut as it was. This is brass, and this is of course then bronze. So I just silver soldered this together, and then we'll mount and test. So this really fixed the problem here. Now I've snugged this up, so I have zero deflection in the system here, which I have also then incorporated two thrust washers in. And then I have modified this nut, just very lazy additional nut. Didn't want to make the complete nut with adjustment and everything, and understood that connects it to the cross slide. So I just added a nut section, silver soldered it, and at least what we accomplish is minimal play here. If we want to, this is as far as it goes. So 2/300 of a millimeter play, and still loose enough to use in any respect. And if we look closer to this unit here, what I've done with this is that I have, as you can see here, it doesn't look pretty, but I've added two rings here because this was broken and here was also bent. So I bent it back as good as I could, and I incorporated, as I said, two thrust washers, one on this side and one on this side. I had to modify this a little bit and also then deepen the hole here to, a recess to fit the somewhat larger diameter thrust washer there on that side. And here, as you can see, the additional 2 rings that I used to reinforce this area, and I've silver soldered this together. They were broken off, as you may remember, every one of them. So I thought this would be a nicer way to add some rigidity also to it. And now it functions just the way it should. As I said, with minimal backlash. So I'm pretty happy with the way this turned out, but of course this is not meant as a permanent solution either, because what I want to do is of course to add a motor drive, probably direct to this. So I may replace this complete assembly with an assembly retaining this motor.